Now I would like to look at the most important cost drivers to consider. In a product cost calculation, I usually have manufacturing costs, R&D costs, material costs, SG&A costs, and overheads or others. To find out more about the relevance of the different factors, let's quickly go through them. Manufacturing costs primarily contain depreciation for machines and facilities that are used during the manufacturing process. They are very relevant here because we are using a new and costly production technology, and the setup time is quite high. 3D printing seems to be a pretty long process that occupies the machines for a rather long time. Thus, manufacturing costs should be focused on. Material costs can be disregarded due to the relatively small size of the piece we are going to produce. However, depending on the prior knowledge of the candidate I'm talking to, I could take a closer look at the material costs as well. For example, when I interview an engineer, he or she should be able to say more about the measurements, cost items, and so on. R&D costs are the costs for the development of the product. I will ignore them right now, since earlier we have stated that this case is only about the production and selling of the implants and not about the development. Of course, SG&A as well as overheads and others only comprise a small share of product costs in the manufacturing industry, so they can be ignored. At this point, it is important to me that you demonstrate your knowledge of the product cost calculation. However, your words don't necessarily need to be the same as the ones I just used. This especially applies for non-economics and non-finance majors who have a different educational background. Now I would like to focus on the manufacturing costs and give you 2 minutes to develop a possible approach. Here you can see the facts again. It seems like quite a challenging problem. One approach could be to calculate the number of layers, the exposure time, and the setup time. Another one could be to divide the depreciation period by the investment costs and multiply it by the duration per hip printing to get the costs per hip. So we have one approach that considers the investment costs and one approach that breaks down the costs to layers, exposure, and setup time. I think in the end it is important to consider both perspectives and combine them to reach the final goal. Here you can see the approach we used. At the top stream, you can see the exposure time. The second stream shows the coating time. At the bottom, there is the setting time. Let's have a closer look at each one of them. At the first stream, I have my part volume of 30 cubic centimeters and divided by the exposure time of 10 cubic centimeters per hour. The result would be 3 hours per implant. However, don't miss this very important point that can be a trap. When I want to be efficient, I cannot produce just one piece at a time, because if I did that, the two other time components, coating time and setting time, would only be divided by one single part. So, to be efficient, I need to pack as many pieces as possible on the build chamber. To give a quick estimation, about 5 pieces fit on my x-axis of 50 mm and 3 pieces on the y-axis of 70 mm. That makes 15 pieces total and explains how the 45 hours were calculated in the top stream. Now the coating time. Here I need to know how many layers need to be coated. The height of the piece was 100 mm and the layer thickness is 50 micrometers. The height divided by the layer thickness makes the number of layers. The difficulty here is most likely not to come up with the equation, but to convert the unit millimeters 10 to the power of minus 3 meters into micrometers 10 to the power of minus 6 meters. Doing the math, I get 2000 layers. Each layer needs 10 seconds of coating time, so in total that makes 5.6 hours. Let's not forget about the setting time, which needs to be considered in my calculation with 3 hours. In total, that makes 53.6 hours for my 15 parts. Now, I need to calculate the costs. The easiest to do that is via the hourly machine rate. Here, I would say it's 100 per hour and gave you the information if you asked for it. Alternatively, we could calculate with the investment costs, which I would tell you then. Keeping in mind to use shortcuts whenever possible, it is easier to ask for the hourly machine rate than calculated by hand. So when I multiply by the time, or the time by the hourly rate, I get 5,360 euros. Divided by 15, that makes 360 per piece. So the answer to my question if additive manufacturing of hip implants is lucrative is, for now, no. The sales price of 300 euros and production costs of 360 euros are not profitable. Now, I need to ask my second question. What can I do to become profitable again? The structure I need to answer that question is basically a breakdown of the calculation of profit. When I want to improve the economic feasibility of my product, I have two options. I can either increase the sales price or reduce the product costs. The best, obviously, is to do both. I can increase the sales price if I add value to my product, but which additional value does additive manufacturing offer? At the beginning of the case, I already mentioned it. A few units can be produced, so small campaign size, and that makes individualization possible. And I can make use of that complexity advantage to improve the product. That enables me to increase the sales price. Of course, I could also try to reduce my costs. For example, I could reduce the manufacturing time per unit. We just looked at the respective drivers. Moreover, I could reduce the hourly machine rates or the material costs. So that's the first structural approach, and now the question arises. Which tangible actions can I take? Here, creativity is highly appreciated. For example, you could use individualization to create implants with a custom-tailored size instead of the usual standard sizes. That might even improve the surgery process, and if the team of doctors only needed 1 hour less for the implantation, the extra costs of 60 euros for the implant were more than overcompensated. I could also use the complexity advantage to build osseo-integrative surfaces which directly connect with the bone. I was actually able to do this before, but only in a post-processing step. Alternatively, I could reduce production time by packing more pieces on the build chamber at the same time. We calculated with 15, if you remember, but surrounded them with a folding box. If I left that out, maybe I could interdigitate some parts and create room for some more. That's also called nesting and would enable me to produce more parts at a time and therefore decrease costs. Apart from that, bigger machines improve the process parameters. I could also take cheaper machines. For example, an increasing number of Chinese providers is crowding the market with cheaper offers right now. Of course, you need to consider quality aspects here. Other than that, you could further reduce material costs. We didn't focus on these, so it might not be the first aspect in mind, but of course, I could try to somehow reduce the 300 euros per kg of titan. Wrapping it up, I would like to have a look at the most important points during a case like this. There are two categories of success factors I'm looking at. First, my expectations. So what does the candidate need to demonstrate for sure? Second, the enthusiasm factors, which in the end make me say that the case was really well solved. So I would expect the candidate to show excellent quantitative skills during the calculations. They weren't too hard after all, and I could excuse small mistakes. It is important though that the logic of the calculations makes sense. Other than that, an understanding of the production technology must be established. Of course, this is new for you and demands a very high flexibility, but please feel free to ask me if you have any questions. I'm your sparring partner and not the evil scrutinizer. I'm glad to talk to you about how the process works, and in the end, it is important that you develop an understanding for the technical context. It is not the academic vocabulary that counts here, but the content and structure of the different positions should be clear. What gets me really enthusiastic is when the business relevant aspects are identified as well. So when you come up with them right away and add some industry knowledge for the case. For example, if you knew directly that I can pack more than one piece on the building chamber, that's a highly business relevant point, and of course the producer would think of it right away. Another example is when you look at the prioritization of the different cost factors. A candidate who knows the industry and already got in touch with mechanical engineering and plant construction should know right away that SG&A costs only play a minor role here. So, due to your prior knowledge, you should set the right focus to get me enthusiastic. Also, go for a simple approach whenever possible. For example, don't calculate the hourly machine rate, but just ask for it. If you already know something about 3D printing, that's also a plus, and you should show it to us and apply your knowledge during the case.